Today what we're going to be looking into is we're going to look at a different way that we can measure angles. Okay, so instead of angles measured in degrees that we spent a lot of time with last time, we're going to talk about angles measured in radians. Now, some of you may have heard this concept called a radian before, and some of you are going, I don't know what this is at all. Is this a word that's really a word? What's going to happen to us a lot of times when we come across a word we may not be familiar with, we start to look at the word, we try to start breaking it down into some parts, maybe thinking about what might be a root of that word, what might be a kind of a central core of that word. Is there anything that somewhat stands out in that word that you say, that kind of looks like another word I might know? Radius. Good. Because that's what I want you to look for. So, the concept of the radian is the concept that if I have the radius for my circle, and I want to take a measuring device that will allow me to approximate the radius of my circle, but I need to do this along the edge of the circle. So I know last time in class we talked a little bit about the arc length, and I call it a piece of pizza crust. And we mentioned the fact that that crust is not always easy to measure because it's got curvature to it. And so the same thing is true of our circle and our radius. So I'm going to hopefully approximate the radius of my circle, and I've got a measuring device here that is flexible enough that I hope I can get it to follow the side of the circle, which is going to be right about there. And so what I've done is I've measured out here one radius along the edge of the circle. When I measure one radius on the edge of the circle, then the angle that is formed here, this angle is now called 1 radian. And then we continue to measure around the circle. We determine how many radians we have going around the circle. But the measurement of a radian is not some amount of rotation. It is physically measuring part of the length of our radius on the rim of the circle. That's how we're doing it. So it's a physical measurement. That's why we begin to use it a lot more in physics. Chemistry uses it a little bit, but generally physics uses it, and other application areas use it. Questions about that? Yes?
So why is the blue one, the one radius, as long as it is? Like, why isn't it shorter or longer?
It is exactly the same length as this radius here. So this is a radius, this is also a radius along the circle.
So there should be like just about 6 of those?
There's actually just over 6 of those radii. Then when you measure around the circle, there's just over 6 radii on the circle. Is there a way we could be a little more accurate with how many radii are on the circle?
I don't know. It's a part of pi, isn't it?
It is part of pi. Let's go back to our memory for just a minute. If I want to find the circumference of my circle, what was that formula?
Pi d. 2 pi r.
Pi times diameter or 2 pi times radius. And so, if my radius is 1 unit long, that means it could be 1 foot, 1 inch, 1 centimeter, 1 kilometer, 1 whatever. It's 1 unit, whatever that length is. Let R equal 1 unit. Yeah, LET. Let R equal 1 unit. then the circumference is equal to 2 times pi times 1, which means the circumference is 2 pi units. And if you want to approximate that, 6.28 something units. Which means just over 6 radii are around the outside of the circle. If we want to be exact, we will say it's 2 pi radians are on the outside of the circle. That makes sense? Good. All right. We're trying to open up a whole new world for you guys. It's great. Yes?
So the angle one is called a radian, and then the radius on the outside is called a radian too?
What we're saying is the length of this arc here is equivalent to 1 radius. So the amount of an angle sweep that creates, we're calling 1 radian as an angle descriptor. I'm being a little bit picky about how I'm saying these words. Eventually, I think that's going to provide a lot more meaning to you. Right now, you're saying it's radius, radian. They aren't really the same word. They're actually really not. Okay. It's going to take us a little time to be more comfortable with how these pieces are fitting together, though. Okay. So this is a radian. And now what we want to do is begin to talk about, if we go all the way around, where do our quadrants start and stop in terms of radian numbers. And we're going to want to talk about in what quadrant a radian angle might land. We're going to want to talk about complementary and supplementary angles with radians. And we're going to want to talk about arc length and area of a sector with a radian angle instead of a degree angle. So we're going to do all those same topics we did last class period, but we're using radian angles instead of degree angles to do them. The only ones we don't do is degrees, minutes, and seconds. There's not a, I don't know what you want to try to call it. We just call them radians. Okay? Now there's going to be 2 distinct ways that we will notate radian angles. And initially you're going to look at me and think, oh my goodness, this is ridiculous. There's a lot going on. As we get more comfortable with them, you will see how these pieces begin to fit together. And we're going to show you the one that shows up most often, but then there's also the version of the notation you need to understand as well. So that's where we're headed. Questions before we get moving?
No, we're good.
Okay, so let's look at our grid system. Thinking about an angle and standard position, where would we have boundaries happening? And one of the things we just had was 0 radians. Starts right there. Now, I wrote this down a minute ago. I want to see if you were paying attention to it. If I were to completely work all the way around back to here, how many radians exactly would that be?
6.28.
No.
4?
5.2.
2 pi.
2 pi is exactly how far we go. So you go all the way around, it's back to 2 pi. So that means if you only go to here, how much is it?
1 pi.
That is pi radians. Now please remember, the last class period I said we won't use pi as a variable for an angle, right? Part of the reason we won't do that is pi actually is specifically a measure of a particular angle size. Pi radians is that halfway around.
Pi radians.
Now, up here, if all the way to here is pi, how much is it to here?
1/2.
It is 1/2 pi. We're going to write it and say it as pi over 2. Pi over 2 radians. Okay, let's think this through. If this much is 1 pi over 2, this much is 2 pi over 2, this much is
3 pi over 2. Wow.
And then if you really want to get fancy, over here becomes 4 pi over 2, which is the same thing as 2 pi. Because 4 divided by 2 is 2. Okay? So we have some boundary markers here. So if I were to ask you, in what quadrant does a radian angle of 2 pi over 3 land? 2 pi over 3. You have to decide if that 2/3 is more than 1/2 or less than 1/2. You got to decide. Quadrant 2, right? 2 pi over 3 puts you right about here. 3 pi over 3 is here. 1 pi over 3 is here. Sorry, about here. 2 pi over 3 is here. Okay? It's going to take a lot of work because we're going to have to deal with fractions. And I know how much you enjoy dealing with fractions. Let's try this one. In what quadrant does pi over 5 land?
1.
The first one.
First quadrant. Because 1/5 is a lot less than 1/2. So pi over 2 is more than pi over 5. Not liking this, are you?
I do not.
Okay, let's do this a different way then. This next way, some of you might like a little better. We're going to provide some decimal approximations for each of these values, and we can also talk about radians in their decimal approximations. So we still have 0 here, but pi divided by 2. 3.14 divided by 2 is?
No, 3.14 divided by 2. Get another one.
So 1.57 is a decent approximation for right there. What goes right here? Thank you. Now, 3 pi divided by 2 is about what decimal?
4.71. Dang.
Now tell me this one over here.
That's a good guess. You know what?
Okay, 6.2. So now, the other way we can express radians is not with pi as part of the angle measurement. It is as a decimal number. So please tell me with an appropriate number of fingers, in what quadrant is 4 radians?
3.
In what quadrant does 4 radians exist? That's quadrant 3?
Yeah.
Okay. In what quadrant does 7 radians exist?
1.
That's 1, correct? In what quadrant does -3 radians exist?
No.
In what quadrant does -3 radians exist? Quadrant 3.
Wait, repeat the question.
In what quadrant does -3 radians exist?
Oh,
If you're going
yeah.
this way,
Yeah.
and if you go -3.14, you're right here. So you got to be just a little short of that. Quadrant 3.
Right, right.
Bad, isn't it? I'm not always right. I do have my moments.
It's not bad.
I stumped you.